lead. I'll play dumb. Dave, you play semi-intelligent, and Kirsty, you're just a genius. So
some days.
I will be the least competent of the group for tonight. Thank God. Right. I'll do the countdown. John, you do the introduction, and then you can introduce me. Then Dave. Then Kirsty as our additional guest. Yeah.
Yeah, that's all right. Yeah.
No pressure. No pressure. And in 5.
Hello and welcome to the E5 podcast. I'm JW, and today we're going to be talking about surge protection. And with me today is Paul Meenan, got David Watts, and we have Kirsty Johnson from Surge Protection Devices Limited.
Hello, John. How are you?
Yeah, we're doing okay. I mean, we're not doing a whole lot of work at the moment because of the virus closed downs, but we're getting along, and gives us more time to do with these nice podcasts and all kinds of other things.
Indeed.
So first of all, then, on the surge protection thing, we've got this situation about, do we need a fuse or a circuit breaker with our surge protection device, or do we not? Because we've all seen certain manufacturers who are supplying things without them. Some have got them built into the device, and of course others have them as a separate device in there. So think of what do you think about that one, Kirsty? What's your view on whether we need a protective device or not?
This has been quite an interesting one. It's come up quite recently. If you look back at BS 7671, I'm going to get my book now so Paul doesn't quote reg numbers at me and I get it wrong.
He does that.
I know the regulations.
You can tell when
I might not be able to quote.
You look at his face and he looks to the left. He's looking at the screen.
I've actually got the printed version in front of me. Thank you very much.
Of course you do. So there's a few things that the regs tell us about this. So it does tell us that we should have I'm just trying to find the right page now. It should have a overcurrent protection device in front. So all the diagrams that the regs give us about our I'm sorry guys, I'm really struggling to find my page.
The SPDs.
Are you ill with corona by any chance?
I
mean the drink, not the actual virus, by the way.
Are you referring to the appendices diagrams?
I am referring to the connection diagrams where we talk about lengths, which I know is something we're going to talk about. Right, here we go. Figure 3.4.8, which just rolls off the tongue, doesn't it? Our connection of SPD. So it tells us here that we should have an overcurrent protection device beforehand. That's what it shows us in our diagram.
Yeah, it does.
If we go backwards to 534.4.5, so our actual regulation on this, it states SPD installations shall be protected against overcurrent with respect to short circuits. So that's telling us we have to have some sort of overcurrent in front of. Unfortunately, there is a couple of manufacturers on the market that have deemed that they can use the DNO fuse for this overcurrent protection, which, as we know, we don't do that.
But hang on a minute, Kirsty. I thought the DNO fuse was outside of the scope of BS 7671.
The DNO fuse is outside of the scope of 7671.
Oh, good. I don't feel as stupid anymore. Right. Thank God for that.
We also can't access it, obviously, to maintain it, so it's not something we should use in any of our designs. Well, we can't access it legally. Let's not start the argument about the fact they can access it.
Right.
That's a whole
John
different
can lend you some
conversation.
ceiling pliers if you want.
Exactly. So we also have that, so we shouldn't be using that anyway. But then if we look at the image above that, it does actually show the surge device in the SPDA, which is what they call the surge device and the overcurrent protecting it. It does actually say that is overcurrent protection too. So it's already detailing in the book, in the regulations, telling us that overprotection is already before that, which is what I'd take as the main switch. And OCPD2, I would take as the one feeding the surge device. So we're okay with ones that have either fed from an MCB or have got a fuse in front of. So there is some devices that have got a fuse built into them. Usually you can tell these devices, if you look at the front of them, there'll be double pole devices and maybe have indication on one window but not on the other. That's because the one window indication will generally be a fuse.
What page in the book are you on again? In the appendix?
166. Yeah.
Sorry for my incompetence.
I'm with you, Kirsty.
Sorry.
on the wrong page.
Yeah, so in 534.4, it does say that this may be internal or external. So there are some manufacturers, as I said, that do it internally. So they build a fuse into their device, and that is absolutely fine. Or we feed them from an MCB. Again, that's absolutely fine. We've got our overcurrent. The ones that I'm taking issue with currently on the market are the ones that do not have that device at all. They are relying on the main switch. And obviously, if we've already said we can't use the main switch, then if we go on to 534.4.5.2, I don't know where they come up with these numbers. It's ridiculous.
Top of the next page.
Yeah, top of the next page.
Europe.
Europe, that's it. In case of overcurrent protection device operation arising from SPD failure, the continuity of the supply to the equipment is unaffected. If we blow the main switch to the property, we've got no supply.
Well, yeah, the continuity is affected.
Exactly. So they can't do that in any way. Unfortunately, these devices are still available on the market, and I'm slowly working my way around speaking to people so they're aware that they actually do not conform to regulations. But it's an issue we're having.
Were any of these in John Ward's? John, have you blown one of these up in any of your videos? Because you're on like video 6 now on your
not one of these. No, I have mentioned one in a previous video from a certain manufacturer that does not have a fuse in the particular device, and there's another point here as well. There's another manufacturer, which we also won't name here, who does put a fuse inside their surge protection device, but according to what's written on the outside of the casing, it's a 125 amp fuse. So how is that going to fit in with, so 125 amp fuse, how is that going to fit in, bearing in mind that most domestics have only got up to 100 amp fuse in the main supply, and in some cases only 60 or 80 amps. So
yeah, but John, you've forgotten that 125 amp is the new 60 amp, isn't it? Really, in certain countries, you're not working it. It's kind of double with a little bit of tolerance on. Honestly, man, do you not get understand all this discrimination and selectivity stuff?
Yeah, so that went with selectivity anyway. Is there a marker? Is there a marker or sign that SPD manufacturers are supposed to put onto the devices to indicate to electricians when they select them that they do or do not have overcurrent protection internally?
It's not something they've done before now because, as I said in the last podcast, it was something we did discuss last time. There was only a few surge protection manufacturers on the market, or anyone that produced surge, because it was such a niche thing until these regs come out. So there's a lot of now the companies I've found that are doing this and doing things wrong are companies that have jumped on the market with a device, possibly from the Far East, basically saying, we've got this device, we'll sell it to you at this cheap price. But actually, they don't understand the workings of it or the regulations behind it.
There appears to be a lot of bad stuff coming from the Far East and around the world at the moment, not just their products.
There is.
So, I mean, the specific requirement then is we can see it obviously in BS 7671. We can see that this is a standard that's not European or British standard. It's an international standard. So would it not be considered that anything from the East should also comply with this?
Yeah,
from
it definitely should.
Perspective?
If they're being installed in UK premises, they should comply with this book. They should comply with our installation. So it's not just. I actually spoke to the owner of one of these companies. I will say owner and not technician. And the response was, yes, the owner was that the response was essentially that the wholesaler should be telling them that they should be installing an MCB up front, even if these devices in some cases are pre-wired into the boards. So we'd have to actually undo the wiring. Apparently the wholesaler should be the conduit to this information, which I then informed them that we should not use the wholesale distribution for any sort of technical distribution of information. And he said, well, if the contractors should be up to guide on their regs, they should know if they're installing that, they should be putting an MCB up front.
Yeah, using the wholesaler as any kind of technical guidance really is a massive bust, because we've all been in the wholesalers and they're basically there to sell products. They don't care whether they're compliant with anything, and that applies to any product of any kind. So, yeah.
But without trying to throw any wholesalers into an issue here, I mean, from my personal observations, quite often they tend to try to make things sound easier and simpler to sell things to the wider demographic of less specialist personnel. So from my observations of the advice from wholesalers, it's often incorrect and it's often try to simplify or,
Yeah,
and quite often you'll find wholesalers don't understand themselves.
No.
They're not electricians. They don't have to read our book. They don't have to understand our book. They just need to be able to sell you a product that you choose off the shelf. They're not there designed to give you this sort of information.
Yeah, and if you go in there, if they're going to be selling a psycho consumer unit that's already preloaded with a surge protection device fitted in it, nobody is going to question that. They're just going to buy that, screw it on the wall and fit it in, assuming that because it's already in there and wired into the switch or whatever, that it's already compliant and meets the requirements. But of course, in some
the
cases,
best will in the world. Nobody's going to undo the wiring of a pre-wired board to put an MCB because they think they know better than the consumer unit manufacturer.
Yeah. So it's not going to happen. And also, in some cases, if it's wired in, you're not going to be able to actually physically adjust the consumer unit to fit in, say, an additional circuit breaker or whatever, because of the way it's been installed by the manufacturer.
Exactly.
Right. You're right,
I'm zipping my lips. I just heard things, and I've
done something with an SPD at home.
No. Well, I know what I've done with my SPD at home, because that SPD at home will eventually be melted by Mr. JW.
Right.
But I have too much experience of manufacturers. No offense, Kirsty, especially consumer unit manufacturers. They're not very good at owning up when they have screwed up. To be honest with you, and yeah, worrying to say the least. But fascinating, absolutely fascinating. We shouldn't be using the DNO fuses as overcurrent protective devices. It's out of scope of 7671.
I mean, that mention there of needing to have continuity of the supply immediately raises any question of using a supply fuse as it's how you interpret it. No, that says you must have continuity of the supply in the failure of the overcurrent protected device.
But it'd be interesting to get other manufacturers on a podcast and let them explain how they made their technical decision and how they interpreted that regulation. Yeah. So come along, come to the fun podcast and explain yourselves.
Yeah, and the thing is, if you're going to use, even if they were going to use that DNO fuse, which of course they shouldn't, the thing is that in certainly say domestics, you can't guarantee what kind of fuse that's actually going to be, because it could be one of several different values. So assuming they said, it needs, say, 100 amp fuse, what if it's a 60 or an 80 or something, or even a 40 in some cases? So it doesn't really fit in from a technical perspective anyway, simply because you've got no control over what that fuse actually is going to be.
And there's another thing as well. When we start building these devices into the boards, it takes out the consideration of the contractor thinking about what type they need to be installing. I mean, I know this is something you've covered, John. So in certain circumstances, we need a Type 1 device. So if we're dealing with a building directly fed by overheads or an external lightning protection system, they need to have a Type 1 on the main incomer. These boards are all being pre-built with a Type 2 in. So it's stopping the contractors even thinking about it. They're just saying, I need a surge device, and buying a board with it fitted in.
Yeah, that's right. I mean, in some areas, it's probably going to be Type 2 pretty much for everything. But certainly like here in Dorset, the vast majority of Dorset is rural, and massive swathes of it have overhead supplies. So you're not going to be putting your Type 2s in there. So obviously it's, just leading people down that path of just fitting a thing is not really going to work in a lot of places, certainly, I'd say, like around here.
It's the danger of creating a common rule framework, isn't it? And removing the need for individual thought.
I mean, that's a specific struggle when you package a board. You know, I mean, we're just also now talking about, RCD types. The manufacturers initially have said, this is nothing new. This something electricians should have always thought about. But, boards throughout the life of the 17th edition were always packaged with AC RCDs as standard. And that stops the thinking process. Electricians have to think about the selection of the RCD beyond, obviously, the I delta N. If they think about the type of the RCD, then they maintain that thought process. And it's the same here with SPDs. They've got to. It should really be requested to select the type at the point of construction.
When I first heard about RCDs, I was told by my tutor in college, basically, there's something called an RCD. They're not worth a wank, excuse my language. You probably won't be using them where you are. And in a domestic house, they just put one on either side of the board, and if it trips, you lose half the house, job and knock. They weren't explaining the fundamental principles of earth leakage, I delta N, residual current, what it was, what protective conductor leakage was, equipment leakage. They weren't explaining any of that. There are generations of sparks out there who just know an RCD trips really, really quickly. But if you say to them, describe the fundamental principle of the difference between an MCB and an RCD, you just get a lot of quiet faces, and that's fine. That's kind of one of the reasons why we bring that rig around. We get the youngsters around it, and we've got the MCB, the RCD, the AFDD, and we remind them without embarrassing them, actually, these are the components of an MCB, these are the components of an RCD, this is the components of arc faults, so they can create a learning framework in their head. Anyway, sorry, I know I'm ranting, but
I think also with SPD specifically, SPD's been around for many years. They've often been outside of the the boundary of most practicing electricians, because they're always like a specialist selection tool, because they weren't so much a common requirement, which they are now in the 18th edition. But there's just so much information here in BS 7671. There's so much new information. There's so many different little abbreviations and stuff that there's not enough time. I go back to training. There's just not enough time for us to add that little bit of content without increasing the course. And we didn't increase the course. We've kept the course what it was from the 17th edition. We've added this new information on overvoltage protection, and we haven't added extra training time or any extra training effort to deliver it. So a lot of electricians just don't understand this enough still.
Agree, absolutely agree. We were talking about the other week. I was in Devon and Cornwall and giving everybody a whistle-stop tour on AFDD and RCD types and surge protection. And even I didn't have, even though it went over an hour, I didn't have the time to go through every bit. But then I just, when John was there, I just said, ask him. It's a lot easier. But yeah, no, okay, fair enough.
All right, this thing about this thinking process, I mean, it really applies to the whole of the electrical industry, because for a very long time it's just been, oh, this is what you do, this is what you do here, and this is what you do there. So there is a lack of sort of thinking about why you're doing certain things, and it's easy to do because it's really easy to do. If you've done something for like 10 years, it's really easy just to carry on doing it just because that's what you were told from day one. But in a whole load of areas, there's going to have to be a lot more actual consideration of why we're doing a certain thing and what's the point of it.
And I think as we're discussing overcurrent protection right now for SPD, should we just discuss why overcurrent protection is required for the SPD? Because, it's an overvoltage device, it's not a circuit protective device in that concept. So why do we need overcurrent protected device for an SPD?
That's a good question.
Is this me? Sorry.
Anyone. I mean, I've got an answer in my head, but it'd be stupid of me to answer my own question. That's all.
That's true.
From my point of view, we always recommend a I'm losing my teeth. An overvoltage device has a overcurrent device before it, because we want to protect the components in the overvoltage device. Essentially, we want to protect them from any sort of short circuit currents or anything like that. We've also got to consider protecting the key piece of cable that we're using to feed this device at the end of the day. So that's pretty much why we use these overcurrent devices.
So a lot of electricians will be thinking, oh, it's a passive device. It's just sitting there on its own. It's just there to tolerate the voltage. Boom, boom, boom. What's it got to do with current carrying? It doesn't carry current, so what's the problem? It does, as you say, it has components within it which have limiting currents, just like RCDs would. So we have to select RCDs for a rated current. And I think a lot of electricians don't really understand or think about that part of it, which is why we need to consider overcurrent protection. I just wanted to add that as we're talking about overcurrent
but you
protection.
need to protect any part of an installation from short circuit currents anyway, wouldn't you? That's why we select and erect breakers with KA values, etc., and we understand what earth fault impedances are, so we can understand short circuit and earth fault currents, so that we can understand.
I've seen it referenced many times that they just say, well, we don't worry about cables because there's questions about, and we can cover this with the length later on. If I'm going to have length, why can't I just increase my cable size and make the cables longer? I see Kirsty with a smirk. We're going to cover this later on, obviously.
Yeah, I get asked that a lot.
Yeah, because that's the theory. That's the theory electricians have about cable current carrying capacities and how we can understand the adjustments with their length and their size, etc. Cable current limits, the devices, components. That's why we need overcurrent protection device. I'm going to little marker. When we talk about cable lengths, I will bring that up so we don't actually forget to cover that later.
Okay, so that's overcurrent protection devices. So yes, they are needed, and really we should not be relying on the DNO or the supplier's fuse there, because that's not its sole purpose. So beware what you're buying and fitting, I think, at the moment, because there are various devices on the market from various places, and they all seem to have different ideas on exactly what is required. Now, the next point here we'll move on to now is manufacturers' assemblies and what you can and can't put inside a particular box from a particular manufacturer. And specifically, there is a regulation which we've covered in a previous episode. This is the deal. If you buy a consumer unit, say from manufacturer A, and it doesn't have surge protection in, do you buy surge protection from manufacturer B and put it in the consumer unit from manufacturer A? Are you allowed to do it? And if you are, what are the considerations you've got to think about if you're going to do that?
So you're suggesting that I wouldn't have to install an SPD from manufacturer A if I bought a board from manufacturer A. I could potentially buy an SPD from manufacturer B.
Well, that is an option. However,
wait a minute, John. Are you saying that you can't be suggesting what I think you suggest? Are you telling me that that day you sat on my couch and we recorded a conversation couch, which is available on YouTube, that we actually covered this in incredible level of detail? Even some wizard of editing managed to put the extracts of the regs on the screen as we were reading them out. We went into this in a bit of detail, didn't we? And we kind of debunked the whole you have to use this SPD device with this assembly. I'm just trying to remember the reg number because hey, I'm just a little bit tired tonight. So does anybody remember the reg number about the assemblies? I can't. I'm quite embarrassed to say I can't remember it.
It is 536.4.203. So looking at page 180.
I knew that. See, I was just testing.
I was nearly there, but 536 is really big. Okay, 180. Thank you, Kirsty. Right.
Yeah, this is integration of devices and components, which so we have covered previously, and
all these lovely notes here.
Yeah, the pertinent part is that I'll just read it, so I can cover that. In low voltage assemblies to the BSEN 61439 series, for example, consumer units, distribution boards, incorporated devices and components shall only be those declared suitable according to the assembly manufacturer's instructions or literature. So that part is basically saying if you're going to buy it from manufacturer A, what you put in is also from manufacturer A.
It reads that way, doesn't it?
However, of course, there's always a however with regulations. Yes, there's a couple of notes underneath, and it says in note number 2, incorporated components inside the assembly can be from different manufacturers. And then it's essential that all incorporated components should have had their compatibility for the final enclosed arrangements verified by the original manufacturer and be assembled in accordance with the instructions. And essentially it goes on to at the end that if an assembly deviates from the original manufacturer's instructions or includes components not included in the original verification, the person introducing the deviation becomes the original manufacturer with the corresponding obligations.
Ooh. That sounds like me then, when I like to introduce new things. Yeah, I think in our little ramble, John, I use myself as an example because I'm a client and I can pretty much do what I want as long as I justify it. Look, one of my favourite regulations in Chapter 1, installations in premises subject to licensing, which is really interesting because railways are subject to licence, pubs and clubs are subject to licensing, so are nuclear reactors and various other places. So they can generally build and mix any assembly they want as long as they've done the due diligence, which is really kind of key, to be honest with you. But yeah, there's some.
In layman's terms, does this mean that if manufacturer A makes a board and they say you must install an SPD to fight by manufacturer A, if an SPD by manufacturer B says, oh no, you can put it in that board by manufacturer A, but now manufacturer B has to take accountability for the final construction. Is that correct?
That's kind of
I'm trying to simplify this in my mind.
What's your view, Kirsty? Once she's
about right?
Well, the first thing I'd like to say is straight away, yeah, you are right. When you take manufacturer, when you start putting things in other people's boards, you've got to be very careful. And I completely agree with this regulation in terms of us not buying manufacturer A's board and putting manufacturer B's MCBs in it. I completely get that. Let's not start bending the buzz bar and doing stupid things to a board to make them fit. It's just not something we need to do. What I disagree with is when we start covering this, the whole, each part we could ever think about, anything we could put in a consumer unit into this regulation, because it's not what these regulations were built for. And if we go back to our original, the principles at the beginning of the book, we say the regulations don't apply to electrical equipment. The regulations only apply as far as the installation is concerned. They do not deal with requirements for the construction of assemblies, but yet for me, this regulation sounds like it's overstepping that boundary.
Well, it sounds like a double standard completely. It sounds like one committee has said one thing and another committee has forgotten to update the beginning bit. So they've potentially overstepped their boundaries as regards to fundamental principles.
That's it. I
Just
think what we've also... Carry on. Sorry, carry on, Paul.
So no, it's just a view. One thing I know is I think anyone who teaches this book or reads this book enough, the more amendments and additions that come out, you see gaps. You see entire gaps. The easiest one being the AM7 DC and an AC network, where it's 17 years of no information and yet referring a reg that doesn't exist. Spelling errors, typos, mistakes, poor referencing, and this is why I always say to people, chapter 1, fundamental principles, all of that section there is the backbone of what you're doing and you're working from. If there's something buried in section 5, it almost becomes preferential in the way it's narrated. That's the way I've always seen it. I mean, for example, so I can't, if I follow that note, that reg, I want to put a Ring doorbell in, and I have to put a power transformer into the board. How do I do that?
Apparently you
Well, if I've got something that can mount on the DIN rail. What about, we all remember loads of, years, okay, and this is me showing my age, but loads and loads and loads of boards used to have little microelectronic transformers with a little 2-core flex going to the front door with your mains doorbell. Did that ever comply? I know guys at, is it Hochiki, who do CCTV cameras. They now do their own version of a Ring doorbell where they've got something that goes in the mains. Are they compliant? I just think there's a madness and a bit of protectionism going on there, which is bullshit.
I mean, definitely when we start having a look back through the regulations, I mean, this integration of device and components hasn't just appeared from nowhere. They're taking this from BSEN 61439. Unfortunately, it's been taken out of context. I mean, if you go back to these regulations, it actually states on the first page of these regulations, it does not apply to individual devices and self-contained components. That's one of the first lines in the regulation, which for me, yes. A surge device is a self-contained device.
So with 61439 in consideration, what was the intention here? What was the anticipated end goal?
Well, this regulation was designed to, it's what gave us, for anyone who doesn't know, who's listening, doesn't know anything about 61439, and to be quite honest, most of you probably won't. It was the regulation that gave us metal consumer units. It was the one that started to up our thermal testing, things like that, to make them safer units, which I completely understand. So they've taken that one step further now by saying anything that goes into that board must be assembled, must be tested by the manufacturer, if they're not self-contained components, which I completely understand again. So now we're talking about things that are going to exhaust gases or anything like that. Yeah. So things like your MCBs and whatnot that will exhaust. That's absolutely fine. What's not fine is when manufacturers start taking this that one step further and saying, actually, we can apply this to anything we can make good profit on, and we'll apply this to any product that will go in a consumer unit, because that just doesn't stand up.
See, I can understand why they would say that from an assembly perspective, from an EMC perspective, where they have, say they produce a 12-way consumer unit and they want to test 12 RCBOs in it. Yes, they have to group them together, run them at a certain load, measure the radiated emissions, the conducted emissions, look at the thermal stresses, the heat generated and all that as an assembly. I get that, but this is an inert passive device, which only deals with voltage.
Yeah, that's an important point, because there's a huge difference between, say, devices that are wired in and actually going to be carrying current continuously, like RCBOs and circuit breakers, whatever, because these things have magnetic parts inside, they've got electronics inside, they can heat up in operation.
See? Yep. Thank you, John. Even John gets it.
There's a world of difference between those devices and, say, something like a surge protector device or a doorbell transformer, which is not obviously going to be involved with those sorts of things.
My man. There we go. By the way, Kirsty, people will be watching this as well, because we're not putting the Simpsons pictures on the videos anymore. So everyone will be watching.
You should have told me that before. I would have put some makeup on or something.
That's right. Don't worry. I've been putting makeup on for hours. John was late because he was doing his hair and putting his makeup on. So we're all looking fabulous, darling.
Oh, he's done that for me a couple of times now. He didn't even tell me. Don't even know.
At least you told me.
Because I'm editing these at like 1 a.m. in the morning. I'm just like, sod it, just put it up. And also, a lot of people have requested on the YouTube ones that they actually want to see us. So, hello. Anyway,
thank you.
So, when we go back to 61439, there is actually a mention of surge protection devices in this.
All right.
Oh, okay.
Which everyone seems to have conveniently forgotten when these manufacturers are quoting this regulation to me.
I bet you John hasn't.
Oh, of course, John won't have. So 9.1.4, which is in 61439 part 1, because there is several parts, it says when overvoltage conditions require surge protection devices to be connected to the main circuit, such SPDs shall be protected to prevent the uncontrolled short circuit coordinations as specified by the SPD manufacturer. I just feel I need to point out it says SPD manufacturer and not assembly manufacturer.
Oh dear, is that? Have we ever heard of standards conflicting and clashing? Where have I heard of that before?
Never.
1362 Part 2 by any chance? Anyway, sorry, carry on. It's just brought back some memories of a comment on my USB video where it's not 30, is it 1362? I think it's 1363 Part 2. Socket outlets, there's a line at the end of it which says where an installation has a surge protection device that effectively it can break down the USB components in the back of the sockets. It can be thermal effects which can cause harm, which is really interesting considering the socket outlet standard was amended last year at the same time as the DPC for the 18th edition came out, and this one says surge protection, but there's a potential danger, and then the regulations say surge protection. So I always used to think, what do I do? What do I do here? Everybody's got USBs in their sockets now. Quite interesting. And of course, there's no data or information on that, but we could probably do another podcast on that, Kirsty. Well, let's leave that for another one.
Yep. Sorry, Kirsty, what number was that from 61439?
Dave, you've got it in front of you, haven't you?
I have. Sorry, Kirsty's gone muted.
I keep trying to do it so I don't cause background noise, and then I forget to unmute myself. It's delightful. Yeah, 9.1.4.
9.1.4, thank you.
In the first part.
Okay, cool.
So unfortunately, I don't blame the sales staff that are out talking about this, because to be quite honest, sales staff are sales staff. What I'm not impressed with is when people know better, and I know they know better, still quoting these regulations and getting them wrong. That's not okay. And it's misleading the electricians we've got out doing these jobs.
Well, there's 2 points to that. I mean, the technical information on offer to electricians at things like these exhibitions, these events, or even in wholesale, there is a real, when you're talking to people that are scripting, with and they're saying the best things and best things and best things, but if you just peel a couple of layers and you ask a couple of questions, you've met the limit of their knowledge. And a lot of times electricians don't really have, you're probably one of the exceptions, but when you're at an exhibition, a lot of the guys who actually have that information, they sometimes hide, or they just don't really, they drift around, and they're not often there at the front to say, what do you want to know? How can I help? It is quite infuriating sometimes.
I've just found a mistake in BS 1363-2 2016. Sorry, it's very random, isn't it?
Why are you reading a standard in the middle of a podcast, Paul?
Sorry, it's just, when sometimes your brain just says there's something wrong here. I've just found a mistake. Section I 4.2. I know we're very random. Apologies to all the listeners, but we genuinely do read all this stuff. It's really weird. I found a mistake. Okay, sorry. We'll leave this in another podcast. Apologies. Yeah. I'll mute my mic. Sorry.
Have we concluded this little discussion about manufacturer assemblies then? Have we concluded this?
I'd just say the most important thing, Paul, is just to be smart when we're looking at things. Do your research. Don't just take what a salesperson is saying to you as fact. Go and speak to somebody who knows what they're talking about, who can speak to you off a script, as you were just saying, just literally talk to you about your installation. If they can start actually applying things to your installation and not work from a script, it's very easy to see sort of who's going to be giving you the right information.
Sorry.
Yeah, absolutely. Yeah, if this is what we've said in other episodes before, in that we're giving you this information, but don't rely on that on its own. Go and do your own research.
Do the work.
What it is,
Yeah, we are. Some point we're going to get to an episode 100, John, and then episode 100 we consider and go. Everything we've said in the last 99 episodes, it's all lies. We made it all up. None of these standards exist. We were talking gobbledygook. We're the Gobbledygook Society. Just on going back to our first point. The use of the overcurrent protective device being the main DNO fuse. I am holding up said evidence to camera. What if the overcurrent protective device is deemed a red head fuse? Which there are millions of these in the UK. So if you go and buy a board in
Wow.
social housing, and social housing has a red head fuse or a red spot fuse, whatever you want to call it, it's a solid 20 mil bit of conduit. You
Well,
don't
then
have
selectivity is
overcurrent
going to be even
protection.
worse, isn't it? Surely.
But this is, again, this drives the need. Sorry, Kirsty, you're probably wondering, why have I got this on my desk? Yeah, it's really sad. I stole this from John's house. No, it's just a valid point. I do have loads of electrical junk, but not near as much as John's. Them new shelves behind me are just going to be filled with junk. But it's a real danger. So if you guys are working on a domestic house and you see a red head fuse, you need to make sure that board actually does have an MCB protecting it, because this is woefully insufficient. I mean, this will just get red hot and melt the plastic around it. So anyway, sorry, John, back to you, mate. Pardon me.
Yeah, those red fuses, for those that don't know, it is just a solid link inside, so it's not fused at all. It's just basically linking two bits together. So its sole purpose is there to enable people like meter installers to disconnect it and reconnect as required. So let's move on to the next point here, which is some of the myths about surge protection devices. First one of which is lengths of cables or lengths of connecting wires between surge protected devices and certain other things, and which lengths are important and which ones actually don't matter. And then they've also got things like the size of those cables and if that's even significant in any kind of meaningful way. So Kirsty, what's your view on the sort of lengths of cabling or wiring between these devices and the rest of the installation?
It's very important, but what I'm quite surprised as is everyone's picked this up as a new thing. So it's new that it's in the 18th edition, but these are the lengths of cable we have always worked to from surge protection manufacturers' point of view. Essentially, the reason why it gives you up to a metre of cable length in your book, in the regulations to install your surge device. This is taking it from the live conductor through to the earth point on the surge device. It says it shouldn't exceed half a metre, but in no cases a metre.
Yes.
Basically, you need to ignore the half a metre thing. That's just making sure you don't go over the metre. But the big thing you need to stick to is a metre. The reason being, as surge protection manufacturers, we are allowed to let through a certain amount of voltage. This is your let through voltage on your device, and I'm sure it's something you'll have covered in your videos, John. It's one of the key characteristics of a surge device. It's basically, don't get too worried about it when it's saying it's letting voltage through. It's maximum strike. It's allowed to let through a certain amount of energy.
Much like equipment can.
Exactly.
Yeah.
But we have a regulation that we have to work to make sure this total let through voltage is less than 2.5 kV. So when we're calculating that, we have to make sure that we calculate in an amount of let through voltage that's used in the installation. So we use 1 metre of cable, as that gives us 1 kV of volt drop. That's essentially what we use. That's how we make our figure up to make sure that we're not letting through more voltage than we need to. So we've taken into consideration the worst case scenario with installation of them using a meter. But as I said, this isn't something new. It's new that it's in the regs, but if you read any manufacturer's instructions for a surge device for the last 10 years, it'll have been the same information given.
Okay, so you say one meter is 1 kV.
Yes.
And your limit is 2.5 kV. I think that's at category 2, isn't it, from the impulse table? So going back to this thing I mentioned on, why can't I make my cable bigger? Or wouldn't that work? To make the length longer?
Because we couldn't guarantee the volt drop on cable when we make it longer for our installs, because we've done a general calculation on cables that are used specifically to wire these devices to manufacturers' instructions. When we start changing that, we can't guarantee the volt drop on them cables or the type of cable that's being used or whatnot. This is obviously when you use different types of cable, you can look at a different type of volt drop throughout the cable. We need to ensure a standard is used across the board. Sorry,
can I ask a really dumb question now? So what we're talking about for those listening, regulation 534.4.8, connection of 168. All conductors and interconnections to the relevant line to be protected, together with the connections between the SPD and any external overcurrent protective device, shall be kept as short and as straight as possible. And that's one of the key things as well for guys, because in a consumer unit, I've been looking and thinking about how I would dress my cable around the board to get to the earth bar, and then I realized no, watch a JW video and it's straight out the bottom, straight up in a continuous line, keeping it as short as practicable. But it's that measurement of length, isn't it? Really, it's the where I go from my mains origin. Can I achieve that length? Now, there is one board, I can't remember who makes it now, but they have, because in all the boards I've seen, you have the main switch on the right, and then you've got the surge protection next to it. But they're the ones that rely on the main fuse. But then there's some boards where you get the main switch on the right, and right over on the left, the very far left, is then a circuit breaker with an SPD next to it. Now, surely that should be as close to the main switch as practicable. Surely that would help with your lengths. Just views and thoughts here, everybody.
We class, because it's going onto the, basically that MCB on the buzz bar, we don't class the buzz bar as being any length. Basically, it's
So that's
zero
negligible.
resistance, as close. Exactly. So because it's low resistance, we're not worried about that slowing down the capacity of the surge device.
Thanks for that. I didn't think of it like that, but yeah, you bang on. Sorry. Okay, that cheers me up.
So
but again, obviously, if you're installing at the other end of that system, as you said on the far left, after an MCB, so we're considering then installing surge devices after RCDs. There is only certain types of devices on the market you can do that with. They have to be devices that don't leak any current to earth. If you try to do that with some of the standard ones on the market, you triple out your RCDs and mess up your board anyway.
So why straight? Why should I try and keep these cables straight?
Because when the cables get hot, we've got to worry about their current carrying capacity, and we need to make sure when we're getting rid of a surge, we can't guarantee the side of surge we're going to be getting rid of. So when we say 1 meter of volt drop, we're doing that on it carrying up to 10 kV in an 820 your waveform for your surge. When we start bending them, when we get heat spots, we can't guarantee that it can take that sort of level of surge through the cable.
If I had literally 10 centimeters of cable, but I put in a 1 meter cable as a pigtail.
Oh, God, pigtail.
Would that be a bad idea?
I don't know if it's ever a good idea to pigtail your cable.
Dave, if you would pigtail a cable on my railway, I'd shoot you.
Just so you know, for this podcast, I'm asking the dumb questions because I've been asked them before.
Ah, right.
Oh, really? Oh,
okay. Yes. Don't pigtail your cables. So you want to keep them as free as possible so they won't get overheated. For the same reason, we want to make sure it can disperse this surge as fast as possible. The current capacity of the cable is not going to be reduced by getting hot or anything like that. So don't pigtail your cables. Keep them loose.
Make
sure you're not.
Dave.
Exactly.
Think of it as a water pipe. The more bends, the more longer length of run you have. The more pressure you need, the more resistance you get, the more friction, etc. It's the same with the cable.
I see guys trying to make their nice boards nice and neat, and they'll start to actually then put bends in this cable, make it longer than it actually could be for the
my one is going to be a work of art.
We want it nice and straight.
Well, I've found installations, big panels, and I'm talking about massive industrial panels that are the size of a room, where I've gone in and they've had a surge device fitting. Out of interest, I've asked them to open the panel so I can have a look, and they can have up to 3 meter of cable on it because they're taking it all the way around the chassis of the board. Sorry, I know I obviously. Oh, you can see me this time. It's fine. I was explaining with my hands. Yeah. So they've done that. So in fact, the surge device isn't going to work. So one, we've added too much volt drop, and two, quite honestly, the surge is probably going to bypass the surge device before it's done its job.
So what you're saying, Kirsty, in simplicity's terms, is some installations can have surge protection installed that actually are so far away and so long they won't actually do much.
Yeah, so when I do my seminars, I always suggest to customers, to contractors, is go and have a look. Even if they say, oh, I've got a surge device fitted, if you're responsible for looking after that installation, go and have a look and double check it's done to regulation and your cables are happy.
Okay. My last little question on this, because it's always nice me asking people who know this stuff questions, because then I learn and I can think about new ways to kind of repeat this information. So obviously we've got the illustration or figure 534.9 on page 170, which has this illustration of the it's number 2 here, the intermediate earthing terminal, which is obviously, it's like a new magical earth bar that's been installed. The cable there that's marked number 4, which goes from the main earthing terminal to this new intermediate earth terminal, it does say that the length of that is not considered. So why is that not considered? How come that's not part of this?
Essentially, once we've got the surge to the closest earth point, which is what your intermediary earth would be, it will disperse through all your earth points. It's got a very low resistance. It's going to get away as fast as it can. So we don't need to consider that length then further on, because we've essentially got it away from your board.
That's
Cool.
to me the CPC, the main CPC for the board. Number 4 on table.
It could-
It
5,
could be,
3, 4.
but it
Well,
could
one
also be the chassis for a board, for instance, if you're working on a big board rather than taking it back to your earth point. If you're working on a
Again,
metal board.
many boards, many switch rooms, your earth bar's on the wall the
Yeah.
other side of you as you enter into the switch room. Your earth bar's down there, and your switch gear's on the other side of the room, and you've got to find a way to get that bar over to there to make an intermediate earth bar.
Exactly. So bond it to the
So-
chassis of your board. If you're working on a metal board, there's no issue doing that. Just get the surge away as fast as
Get
you
it away
can.
from what? What have we got to get away from then? The
Get it
equipment.
away from your circuit,
Switch
essentially.
gear.
So get it away from your surge device. So make your cable from your surge device to your intermediate to your earth as short as you can. So when the surge
Nice.
device activates, the surge has gone away, basically.
Yeah, the way I've
Now just
explained it on
Pat myself
some
on
of
the back for getting that right.
Yeah, I've done it on some of the videos. Is that it's the distance that's important. Is the distance between the surge protection device and your installation. It's not the distance between that and various
And
other
true
components.
earth and things, yeah.
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 So hence you don't want your surge protection device at the long end of a lead on its own, because obviously that's a huge amount of stuff.
So what you're saying, John, is I can measure my cables from my entry to my consumer unit if I'm working in a domestic house. Is that what you're saying?
Yeah, it's the distance from the. If you've got your tails going to consumer, it's the distance between those and the surge protection device. So it is not the distance between, say, like the main fuse or the incomer or anything else. So it's getting the wires from your device to the, say, the main tails in that particular case as short as possible.
This
I was
is
gonna
where
say,
life
but-
gets.
This is where life gets really complex, because in new builds you have those stupid plastic external meter cupboards, and then they run the tails between the fabric of the building, which sometimes might be protected by a fuse, sometimes may not. And then they go into a consumer unit which is flush in the wall, and you're looking at 2 to 3 meters straight away before your main switch.
So we don't take into consideration that length. What we measure from is from the overcurrent device, which is essentially is where you're splitting your feed from, or where you're taking your feed from. So if you're splitting your tails before they get to your consumer unit, you take your measurement from there. If you're putting off Henley blocks, something like that. If not, you take it from as it comes into your board. So where you take it off your line
Gotcha.
supply. Where this causes an issue, so before we were talking about some companies not using an overcurrent device. If we go by our standard, they should technically be measuring from the main DNO fuse, because they should be measuring the distance from their overcurrent device, which again adds another reason to why you can't use that.
Yeah, and
Wow.
I think the final point here is that we've been talking about voltage drop on the conductors there, and they say it's important to realise that we're not talking about your sort of standard voltage drop that you would have, say, within an installation at sort of 230 volts and 50 hertz, because of course surges are not 50 hertz events.
Well, you actually did was it video 5 where you actually looked at the connecting cable lengths and you actually showed the volt drop, and it's a very good point because we think of volt drop, we relate it to obviously standard 230 volt 50 hertz, don't we?
Yeah, let's say, of course, surges are not that at all.
No.
This is partly why that you can't just shove in, oh, I'll just put a bigger cable in, which is what you do in a normal installation, because that's not going to work, because it's not a resistive thing. It's mainly to do with the inductance of the cabling, because, of course, a surge is a really short, high-frequency event, essentially. So just going for things like, say, a 50 hertz type of thing is simply not going to work. So.
So there's sizing in BS761 obviously between connecting to a type 2 and a type 1 device. Is that just purely because of the anticipated tolerated voltage level that could be there for a type 1?
Exactly. In a type 1, we're looking at a direct lightning strike.
Yeah.
So we are looking up to, the devices rated are up to 100 kA. So using Ohm's law, we're looking at 100,000 volt lightning strike. We need a bigger cable to be able to handle that sort of voltage.
Yeah. Okay, cool.
But yeah, certainly if you making the cables bigger in this case is not going to really help you much with your voltage drop, because it's not that kind of effect there. It's so don't think of it as in terms of a normal circuit and voltage drop, because that's not actually how it's going to work. It's all to do with mainly the inductance of those wires and these sort of very high frequency events there, which is why the length is so critical, because the length is what has the biggest impact on the inductance of those wires.
Awesome.
Now, you mentioned lightning there, which brings us on to our next point here. We've all heard of lightning strikes, but have we heard of lightning strokes? And if we haven't, then we should have done, because there's an important difference between them. Now, Paul, you've done a recent thing which covered some of these things.
Yeah.
So What would be your sort of view on the difference between a strike?
So I thought stroke was stroking my dog, who actually has snuck back in the room and is sat behind me. But there you go. So much for doors. Yeah. So one of the things, this journey of understanding overvoltage issues, transients, and all the rest of it is a real complex one. We've all been on it. I think, John, you're kind of running ahead in the field with all the videos you've done on it. But for me, I like to keep it simple, stupid, the KISS scenario. And a lot of people have asked, we're dealing with lightning strikes, and we have to be very clear that there's another standard, which not many people like, in 4 parts, as I've read the last 4 parts since our last podcast, BSEN 62305, that deals with various issues around lightning protection systems. And that deals with the concept of the strikes, the LPZ zones, the requirements for interconnection of surge on mains, etc., protection of buildings. This stuff in 7671 deals with the stroke, which is the after effect of the lightning strike, and also internal surges and spikes that can occur from switching events. And I like the fact that there's 2 differences between the 2. Kirsty's going to probably say to me, "Don't be stupid, man. You're an idiot. Shut up." But yeah, there is a difference. The 2 terms come from, to me, very clearly 2 different standards.
Is there a definition for them somewhere?
There is a technical difference.
Yes.
For anybody that'd like to know.
Yes, please.
Yes, please.
A strike is when the lightning comes essentially from the cloud to Earth when it hits the Earth.
Yeah.
The stroke is the return path from the Earth back upwards. So a stroke.
I like that.
I know, it's a very simple definition. The stroke essentially can occur up to 20 times during a lightning strike, and this is what generates essentially the current, which causes a lot of problem with the lightning. So it's not necessarily the strike that's causing the damage. The stroke is what causes the electrical damage.
What she said. Yeah. That was a much better explanation than mine. I was trying to take it from standards perspective, but yeah. You see,
standards never get these sort of things right.
This is where we get these manufacturers in who just know their onions. It's fantastic.
So, I mean, a strike, obviously in lightning you'll have many different strikes, but in this electrical term, strike is one event, one strike, and strokes could be numerous events of the pathway returning, in your view. Is that right?
Yeah, so the strike is when it physically comes down. The stroke occurs during the strike.
Yeah.
So during
it can go off in many different routes.
Essentially, yeah. So generally it's going back up, which causes the flow of current, which is what we get a lot of current. That's our issue with lightning. It causes so much damage. So we've got the voltage, which we deal with our surge, but obviously as its follow through current, which is why we have so many electrical fires, things like that, caused by by lightning. So yeah, our strike's coming down, strokes when it's coming back up. The stroke is actually generally the bit you'll see, so it's really, really bright. So that's what makes lightning appear in the sky is actually the stroke. It's the return path, not it actually physically coming down.
Interesting.
Well, that's me educated once again.
Right, I'm going to do some CPD.
Evidently.
That's what I'm going to be doing while I'm locked in.
Yeah, there's tons to do. So there you go. Some new terms, some new ways of thinking, strikes and strokes. Who would have knew, eh? There's a difference. Okay.
Right.
What's next?
Was there any more myths to debunk?
I've got one, if we can discuss it now, but this might have to get edited out.
Oh, here we go.
Okay.
Controversy.
They're my favourite.
So I'm going to quote, because I have still got it in front of me. Section I, because this is bugging me now, because this is a mistake. Section I, 4.1 of BS 1363-2 2016 says, surge protection devices incorporated into socket outlets shall conform with requirements of I 4.2. I can actually send this to you, by the way, Kirsty, on WhatsApp, so you can have it. Not the standard, but the actual presentation, by the way, because I don't do that sort of thing. Right, note
Obviously.
1. It says the use of SPDs, variously known as voltage-dependent resistors, gas discharge tubes, avalanche breakdown diodes, and similar devices, might have particular applications and restrictions in their use in many safety standards. It then goes on to say, and this is me reading it verbatim, the slow deterioration of surge protection devices with time might result in an increase in leakage current. I could have swore they were passive and they dealt with voltage.
So what they're talking about are devices that, I was saying before that we could only install a device after the RCD if it doesn't leak any current to earth.
Yeah.
That's the reason why. So when they're brand new devices, they won't leak any current. But as the MOV, essentially what we use inside, which is the one bit that can vary its resistance, starts to degrade, it will start to leak current to earth. So in our devices, we use a gas discharge tube as a secondary part to ensure that as that starts to degrade, it can't leak any current, trip your RCDs. That essentially is the bit that people are getting wrong if they're installing after the RCD with no protection.
Right, because it then goes on to say this can cause a permanent and continuous increasing temperature stress, which can cause the component to burn or burst. Thus, SPDs are regarded as potential safety hazards. And this is the British standard for socket outlets with USBs. So I'm thinking someone in the JPEL committee might want to have a chat with someone in the 1363 committee. Oh, Kirsty.
Yeah, I think perhaps they might have to with that, yeah.
I will send that to you now.
That's it. I want to put people's mind at ease. Surge protection devices are designed to fail safe if they start to... When they essentially can't, the way surge protection works, I can't remember if we went through this last time, is essentially as the voltage comes up on the board, the resistance will go down through the device to create an easier path to earth. So the MOV will make its resistance pretty much zero. And then when the voltage is gone, the resistance comes back up through the device. That's how they work. So when this MOV starts to degrade, as I was saying, it will start to leak current. So we use a secondary device called a gas discharge tube, which essentially stops this current leaking to earth. If these devices get to the point that they can't vary their resistance anymore, they fail safe, meaning they will fail without sending your surges away to earth. The resistance will fail at top, so it just won't vary its resistance to lower anymore, which means it won't take any current. It's not pulling a load or anything like that anyway.
So it just becomes a dead solid resistor.
Exactly. It's just inert. It's completely unreactive. It's not going to become dangerous. I don't want anyone thinking after listening to that it's going to become dangerous in their board or a safety hazard. They're not designed in that way.
Okay, we go back to the myths then. Here's another one which this has come up quite a few times. Everyone's familiar with these like extension leads and things you can buy, which have got basically a Type 3 surge protection device in it.
Yep.
And several people have already said, well, if I've got to get this plugged in my TV, why do I need one in my consumer unit, and why do I need all this other stuff suddenly? So, Kirsty, what's your view with that one?
My view is, first of all, SPDs that go into sockets are actually covered by the regs Paul was just speaking about. They don't sound like they know too much about what they're talking about when it comes to SPDs. They're not SPD manufacturers. They don't necessarily understand the ins and outs of SPDs. So they don't conform to our standards, is what I'm saying. They're not monitorable. Generally, they don't have indication on, if any, to tell you the surge device is actually active. And sensibly, if we think about the fact, if we're using a training lead, we are protecting that circuit. We're protecting what our TV is plugged into. If we're putting one in our consumer unit, we're protecting the whole installation.
That's a good point, John, because loads of people on social media, they do go, I don't need SPD. I'll just get one of them training leads with an SPD built in, job done, saves me a fortune, in their typical macho, idiotic, stupid, ignorant ways.
So excuse my ignorance, those don't come under 61439? They don't come under the standard 61439?
They don't come under anything that I've ever worked with. It's not something that I've ever come across. No.
Well, ZPD, okay.
Yeah, it's something I'm going to have to look into further. But as far as I'm concerned, any surge device that is able to be sold on our market has to have status indication. Quite often with these surge protection trainers, they don't have any sort of indication. And the level they'll have in them will be a Type 3. So a Type 3 device, the way I explain it generally is if you think of a funnel, the big part of the top is your Type 1, which will take a big lightning strike. Your Type 2 is your next chunk, and your Type 3 is your little bit, meaning that it can take a little amount of energy but lets through a little bit. So it'll make it suitable for your end equipment. So if you're only using a Type 3 component, which essentially is what them training leads will be, they can't necessarily...
There's no previous filtering down, is there?
Exactly. They can't necessarily take a surge as a Type 2 device would.
So I think the one I've got in my office, I think it's got like a let through of 1 kV. It's just on the sticker on the thing. But if I then just chucked that and relied on that to be the sole protection, there's nothing saying it's going to actually work to that.
Exactly.
So I've got just one last question, really, is So at the moment, we have surge protection devices that are put into main switches without overcurrent protection device, because I don't recognise DNO fuses as overcurrent protection device. But if we need overcurrent protection or short circuit protection, I think, John, in one of your videos, didn't it allegedly have how does it indicate when the fuse has gone, or the alleged attempt at fusing? Oh, am I just being really controversial right at the end of this because everybody switched off because they're so bored?
I mean, the one I took apart, in fact, most of them, that one I took apart didn't actually have a fuse in it. It just had that thermal break thing in it, which basically means when it gets hot.
You mean solder?
Melts. Yeah, solder, basically.
Yeah, okay, so, good. Ooh, I thought you were getting technical with me, John.
And a spring pulls the thing down. It indicates that it's basically gone open circuit and no longer works. So that didn't actually have a fuse in. And of course, if it has got a fuse in and that fuse fails, then there's not an indication that it's obviously not working anymore, because it's just a fuse. And we've all seen fuses that are blown. They look exactly the same as fuses that are working perfectly fine.
And the thing is, these surge devices that the fuses are attached to, the built-in unit, the surge device won't activate. The indication on the surge device won't change. So even though it's not getting power to it, the surge device will still be showing green, for instance. It won't let you know that there's anything wrong with that circuit.
I'm going to put my neck on the block and say that I wouldn't recommend the use of surge protection relying on a DNO fuse. There, I've said it. Sue me. And on that bombshell. Right. Are we kind of ready to wrap this one up, Mr. JW, or do you have more controversy for us?
Yeah, I think we've covered all of the controversy we can handle with this particular episode. So we can no doubt cover things in a future episode if all the other things we wanted to talk about are in there. So
yeah, if Kirsty doesn't hate us and never want to speak to us again after this one.
I've got
never happen, guys. Never happen.
I've got one last question for Kirsty.
Go for it.
And that is, where are we as electricians in understanding SPDs when you go out and you speak to us? What can we do, or are we just not understanding it, or is there anything else that we need to learn more about, or what do you recognize as being something that we need to do or get better at?
As with anything in this industry, you've got a range. You've got everything from contractors still telling me, well, I don't need to install it anywhere anyhow. Surge protection isn't needed. You didn't need it in my day 50 years ago and you don't need it now.
Oh, there's so much of that.
Oh, there is so many of that. All the way through to contractors like yourselves, to be honest, even though I know you're not, other than John, not actually acting contractors anymore or at all. You are not, you're not out on site, what I'm saying is I'm really sorry. I feel like I'm offended you guys. But no, I actually tried to give you a compliment here, that I've gone out and done their own research and understand a little bit more about it. There's a massive range. But generally, when you go in the middle, people are just confused. I mean, you've got people, you've got NIC courses, and I don't know if I'm allowed to mention their name, actually. I might get in trouble after that. You've got course providers that are giving courses on 18th edition and skipping surge protection because it's not in their exam. You have...
I love you for saying that.
Can I just say that my one did, when I did it, I had done more reading up on surge protection than the guy who was teaching me, which was really embarrassing, but hey.
Well, I actually asked, what they'd done was the training provider in question, I will not name, actually ran the course at a branch. They were running local wholesale branch courses, the day course, essentially, and they had to take the exam at the end of the day. So I asked if I could sit in because I just wanted to hear what they were learning about to the 18th edition. And he said, yeah, that's fine. So I sat through the entire day. I was very proud of myself. Fortunately, didn't have to take the exam at the end. And when he got to the end of the day, he'd missed the surge protection. When I asked him about it, his first answer was, yes, it's not in the exam, which I was not impressed with. His second was, well, to be honest, I didn't know enough to be able to answer any questions, so I didn't want to speak about it. I thought, well, that's the fundamental problem in the industry. Wow. Exactly.
That's the big problem there, Kirsty, because a lot of trainers won't want to talk about a subject that they are not confident in.
No, that's it.
And they'll still deliver material. They won't update the syllabus. They won't push things forward.
It's a damning, though, of the education sector that there's not steps being made to either do that or... But then again, this is what we're trying to do by going round to colleges, is actually try and helping them in understanding and remembering those basic principles so that they can inspire
show
their
you, though,
learners to go on
If
that
the
journey.
training industry would improve a little bit, this would be so much easier.
Yeah, I know.
That's it. But I think manufacturers have a role in this as well. So not only are the training industries not doing a great job with Surge, because it is quite a niche product. I do get that. It's quite a niche area for them to talk about. Manufacturers or people that are calling themselves manufacturers that aren't are so uneducated on it that they're confusing people as well. They can reiterate regulations, the standard of ways
You're
you put
referring
it.
obviously here that obviously since the 18th edition has obviously gone down this avenue, many manufacturers have just added SPD to a catalogue of products,
Yeah, quite often.
specialising in their technology.
That's it. Quite often, I mean, 99% of the time, if you come across a device on the UK market, it is not that that's not their device. It might have their label on, but it's not their device. It's been designed for them. Exactly. So it's something electricians need to be aware of. So none of that really is helping the training of surge protection. The advice I could give really to anybody listening that wants to learn more about surge protection, contact me directly. I mean, especially at the moment, I'm not exactly rushed off my feet. So if I will log on to Skype like I'm doing right now with you guys and do training sessions on surge protection. I'm completely CPD qualified. I have my certification. So I'm quite happy to do that. There is no cost to any of this. All I want to do is make people have a bit more understanding, feel a bit more confident about this. And when they do, I think they'll start seeing it as a good thing to add to their installation, not this negative.
What's the easiest way for people to have access to you without sounding weird?
Hang on, I've got a phone number. Let me just read it out.
Is it LinkedIn? What's the best way for people to access?
You can contact us on LinkedIn. You can contact me directly on LinkedIn, Kirsty Johnson. I'm right there in my bright yellow jumper, so you can see me on there. We can also contact us through Facebook for our Surge Protection Devices page. And you can also email me directly, and it's just kirsty@surgedevices.co.uk. That is no issue at all, just contacting me and asking me any questions you want to ask. It was a bit weird last week. I was at Elex at Manchester, and I had people coming up to me and going, "You're Kirsty Johnson. You did a podcast with the E5 guys." It was strange. Sorry. But I'm getting used to it.
And you're doing another one, and you don't look like your Simpsons caricature at all.
No. I'm in black today. I've got a new one.
You're far less yellow. I actually prefer the black ones because the company name stands out far more on the black ones.
Yeah, it's a bit more slimming as well, to be honest. So I'm happier with it.
Right, that's why I'm wearing my Pew Pew t-shirt now. I'm so much slimmer in it.
Well, thank you for answering that question. I know that was sprung on you, but I think we need to try and find ways to enhance people's understanding in this.
Kirsty, are you on Twitter, Instagram, the Book of Faces and all that, your company profiles, or is it just LinkedIn?
The company profile is on LinkedIn and Facebook. We're not currently on anything else.
Stay off Twitter. I recommend you stay off Twitter. Instagram would be a cracking place for you guys to venture out, because there are tens of thousands of very good electricians. And also, here's an idea. You can, if you go on Instagram and create a Surge Protection Device Instagram page, you can Instagram live CPD sessions for electricians to join in and advertise it as live. So if you can rig something up, you can. I mean, I'm playing around with it now, aren't I, Dave, on the E5 account, where I do Instagram live, and I'll sit in my car talking or talk about something else. But you can Instagram live a surge protection event.
Oh, I'll have to have a look at that. I don't really do social media.
But what you'll get, Kirsty, is if you follow thousands and thousands of electricians, they'll get notified. If they follow you back, you'll get notified. They'll get notified when you're live. And if you do it at key points in the evening or at lunchtime, you may find that you get like 50 electricians asking you loads of questions, which is a really good way to reach out and stuff. But then we're full of weird ideas. Instagram's cool. Twitter's toxic.
Okay, I'll bear that in mind.
Right, JW, take us home, buddy.
Yeah, well, I think we've covered more than we needed to cover there, so that's absolutely fine for this episode. So thanks to everybody for actually putting up with us this far. And of course, we will be having plenty of episodes in the future on this one. So I'll say thanks for listening. And thanks for my guest as well.
All right, cheers. Bye-bye.
Bye-bye.
Thanks for having me, guys.
Bye.